Hello students, I'm coming to you with the next video lecture on Chapter 2, which covers frequency distributions and graphs. In this video, I will cover the following concepts: frequency distributions and the rules for constructing them, types of frequency distributions, and the application of descriptive statistics to frequency distributions. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the concept of frequency distribution. Apply the concept of levels of measurement to the rules for constructing frequency distributions. Understand and explain the 5 different types of frequency distributions, and apply the concept of descriptive statistics to frequency distributions. So let's first begin by discussing what a frequency distribution is. It is an arrangement of values or attributes that shows the number of times or frequency it occurs in a data set. Frequency distributions help to provide insight on 1, how values or attributes are distributed in the data set, and 2, the overall shape of the distribution of values or attributes in the data set. In terms of rules for constructing a frequency distribution, this is where the concept of levels of measurement come into play. If a variable is measured at the nominal level, frequency distributions are constructed directly from the raw data set. The order in which the attributes are listed doesn't matter since these variables are not quantitative in nature. So let's take the 2 frequency distribution tables to the right as examples. For the first table, which captures the variable marital status, there are 3 attributes: widowed, married, and divorced. For the second table, which captures the variable race, there are 2 attributes: not white and white. Both of these variables are measured at the nominal level and are categorical in nature. It is for these reasons that the attributes do not need to be arranged in any particular order, since these variables are not quantifiable. On the other hand, when constructing a frequency distribution for ordinal, interval, or ratio level variables, you first need to form an array. An array is an ordering of every value or attribute in the data set from lowest to highest. So let's take the variable depression, for example. First, we know that the variable depression is measured at the ratio level because there is a true 0 point. These data are also continuous in nature. The values within this variable are arranged in an array from lowest to highest, with the lowest score in the depression scale being 0 and the highest score being 47. For the second example, which is the variable self-esteem, we know that this variable is measured at the interval level because there is no true 0 point. These data are also continuous in nature. The values within this variable are also arranged from lowest to highest, with 18 being the lowest score on the self-esteem scale and 40 being the highest score on the self-esteem scale. And finally, we have the variable education. This variable is measured at the ordinal level and represents categorical data. The attributes within this variable are arranged from lowest to highest, with less than high school being the lowest level of education and some business school or college being the highest level of education. Now here are the 5 different types of frequency distributions that we will discuss in this segment. Absolute frequency is a statistical term used to describe the number of times a particular value or score appears in a data set. To construct an absolute frequency distribution, we would first need to arrange the values or attributes in an array, eliminating any duplicates. Next, we would need to count the number of times each value or attribute occurs. And finally, we would need to place the frequency count next to each value or attribute. So here's an array of scores for the variable age. As we can see, everyone in our data set ranges in age from 16 to 22. On the right-hand side, you will see our absolute frequency distribution table. In the left column, we have listed all of the ages within our data set, eliminating all duplicates. And next to each age, we have placed the frequency count to reflect the number of times that each age occurs in our data set. So as we can see, we have one 16-year-old in our data set. We have 3 individuals who reported being 17, 3 individuals who reported being 18, and 5 individuals who reported being 19, and so on and so forth. So this is what an absolute frequency distribution table looks like. Next, we have cumulative frequency distributions. Cumulative frequency is a statistical term used to describe a running total of frequencies. Keep that in mind, running total. Cumulative frequency can also be defined as the sum of all previous frequencies up to the current point. So we are continuing to add to our table. So now we are going to add a column for cumulative frequency distribution. So how do we go about getting this running total of frequencies that I mentioned previously? So how we would do this is simply by adding 1 to 3, which would give us 4, adding 4 to 3, which would give us 7, and if we wanted to continue on, we would add 7 to 5 to get 12, 12 to 10 to get 22, 22 to 6 to get 28, and 28 to 2 to get 30. So we have a total of 30 cases in our data set. Essentially what this table is telling us is that there are 4 cases that reported being 17 and younger. There are 12 cases that reported being 19 and younger. And there are 28 cases that reported being 21 and younger. So this is what a cumulative frequency distribution table looks like. Now let's move on to percentage frequency distributions. This type of frequency distribution represents the percentage of each absolute frequency. To generate the absolute percentage, we would simply divide the absolute frequency in each row by the total sample size. So we're adding on yet another row to our table. But this time, we are going to draw from our absolute frequency distribution column in order to get our percentage frequency distribution column. So we would simply divide 1 by 30, which would give us 3%. We would divide 3 by 30, which would give us 10%. And we would divide 5 by 30, which would give us 17%. So what this table is telling us is that 3% of our sample reported being 16. 10% of our sample reported being 17. Another 10% of our sample reported being 18, and so on and so forth. So this is what a percentage frequency distribution table looks like. Now we're moving on to cumulative percentage distributions. This is very similar to the previous type of distribution that I just discussed, except this type of frequency distribution represents the percentage of each cumulative frequency. To generate the cumulative percentage, we would simply divide the cumulative frequency in each row by the total sample size. So we are adding on, yet again, another column to our table. Except this time, we are drawing from our cumulative frequency column in order to generate our cumulative percentage frequency column. So what we would do here is we would simply divide 7 by 30 in order to get 23%. And we would divide 12 by 30 in order to get 40%. And we would do this for each number in our cumulative frequency column. So what this is telling us is that 7 individuals, or 23% of our sample, reported being 18 and younger. In addition, 12 individuals, or 40% of our sample, reported being 19 and younger. So this is what our cumulative percentage frequency column or distribution table would look like. Now let's discuss grouped frequency distributions. Grouped frequency distributions involves transforming ratio or interval level data into ordinal level data with rank order. It reduces data into mutually exclusive and exhaustive groupings or categories. However, it is important to keep in mind that these groupings must be intervals with equal width. These groupings make large data files easier to read, manage, and visualize. And it is also important to note that some measurement precision is lost, as you can no longer pinpoint individual scores or values. So here is an example. We have all of the columns in various frequency distribution tables represented here. So now what we want to do is create a grouped frequency distribution. And there are many different ways to go about doing this. The interval width does not have to be 3. This is just an example. We can choose our interval width. The interval width is totally up to you. But in this case, I've chosen an interval width of 3. So what that means is that each of my intervals have the same width. So 16, 17, 18 is a width of 3. 19, 20, 21 is a width of 3. And 22, 23, and 24, again, is an interval width of 3. So within this first interval of 16 to 18, we have 7 cases. Within this second interval of 19 to 21, we have 21 cases. And in this last interval of 22 to 24, we have 2 cases. Now you might ask where the number 24 comes in, because we have no 24 in our array of scores. But this doesn't matter. As long as our interval widths are equal, this last interval here still captures the endpoint of our distribution. So even though we know that we don't have anyone in our data set that's age 24, we do know that we have 2 individuals that are age 22. And so that's perfectly fine. As I mentioned previously, the other thing to keep in mind is that because we have now grouped our frequencies, we lose the precision that comes along with being able to pinpoint each individual age, as we've done here in our array to the left of the screen. So remember I said that it is always easier to go from continuous data, which is what we have here, to categorical data, which is what we created here. But what we cannot do is go from categorical data to continuous data. So finally, let's talk about the application of all of this to descriptive statistics. What we learned in the last video lecture is that descriptive statistics provides a way of summarizing data. And so the thing to keep in mind about frequency distribution tables is that they create a way of simplifying our data and summarizing our data. Creating frequency distribution tables is often the first step in descriptive statistics because it gives us a way of seeing what all we have in our data set and what the frequency counts are for each attribute or each value within our data set. And so this provides sort of a peek into our data and allows us to know exactly what we're working with. So this is usually the first step, is that we go into the data and we run frequency tables on each of our variables, and it gives us a snapshot of each one. So just keep in mind that frequency distribution tables are the most basic and simplistic way of summarizing and describing our data for ourselves as well as our intended audience. So in summary, we started out by talking about frequency distributions and the rules for constructing them. And we saw how important the concept of level of measurement is when it comes to these rules. So we learned that for variables that are measured at the nominal level, there's no need to construct an array, simply because these variables are not quantifiable. We are able to arrange the attributes within nominal level variables in any order that we choose. However, when it comes to variables that are measured at the ordinal interval and ratio level of measurement, we now know that we first need to arrange those values or attributes in an array before we are able to do our frequency counts for each one. In addition, we also discussed the types of frequency distributions, and we now know that there are 5 main types: absolute frequency distributions, cumulative frequency distributions, percentage frequency distributions, cumulative percentage frequency distributions, and grouped frequency distributions. And finally, we discussed the application of descriptive statistics to frequency distributions. And what we learned is that we typically begin the data analysis process by running frequency tables, which is a part of descriptive analyses. Frequency tables provide the most basic and simplistic way of summarizing and describing our data. Here's a table that outlines each of the definitions of each of the concepts that we have discussed in this video. And finally, I would like to invite you to check for your understanding of these concepts. You can do this in one of 3 ways. You can complete this form here on the left and simply click submit, or you can copy and paste this link into your browser or scan this QR code in order to complete the survey. I hope this has been helpful, and I look forward to seeing you in the next class.